Welcome everybody, my name is Andrea Pham and I give you insights into the blockchain consensus mechanism and fair trades. So first of all, I'm gonna introduce you to the agenda. So first of all, I want to introduce you to myself, what my proficiency is and my interest. And after that, we will go to the introduction about this topic, about the session, so you can have a view why it matters, this consensus mechanism and fair trades. And after that, I will give you a short introduction about blockchain, because there is no official definition on the internet yet, or from a government. This is my definition, what I have found in my research. As I said, there is no official definition of blockchain, so that's why I'm going to explain it to you, so we have the same level what blockchain is. And then I will introduce you to the security threats that exist in the blockchain networks. And after that, I will talk deeper about the consensus mechanism, where like very different mechanisms existing on the market. And in the end, I give you a conclusion about this session. So, who am I? My office is located in Berlin, so I'm living there. And I have the Master of Information System Management at the Technical University of Berlin. I wrote about my master's thesis about blockchain, about risk and chances in the real estate section. And that's why I like to keep talking about it, so I keep my knowledge up to date about blockchain. My proficiency is I am technology consultant at SAP in the practice unit orchestration and architecture. And we are focusing on the SAP APPM solution. It's a solution extension for BPM. It's like a customer wants to digitalize the project, and we are helping them to implement the workflow solution for that. And SAP has a solution called IPPM. And on my free time, I like to running. There is 1 month the marathon, and I'm gonna take part in, so I hope I'm gonna survive. And I like to travel a lot. So my last big destination was India and Nepal, and I just took the backpack and travel around the country. And I can really recommend India and Nepal. And I also love reading books. Currently I'm reading Yuval Noah Harari, Eine kurze Geschichte der Menschheit. I think it's in English, A Brief Introduction to Humankind. And this is really a good book, I can recommend it. And I'm already in page 419 from 510. So it's a good book, I can recommend it. So introduction to this topic. Imagine you work for a company and you have a platform, building platform, something like that, and you did some research like for 6 months or 1 year, and then you said, yes, for our use case, we want to use blockchain because it makes advantage, because not in every use cases blockchain is versus just because it's a new hype. So in your case, you said, yes, it makes sense, I want to use blockchain. So you go to the market and think about, I want to use where are the providers and services, and then you find like this one. And there exist so many application provider services, platform as a services on the market, and you just were like, hey, there's so many apps, which one should I use? So it's just to choose the right one. You have to select, and you have to some requirements about what is your goal and about meet the strategy. So first of all, you need like requirements, and where some of the requirements it can be more due to your goal or strategy. And one would be the quality. It's like performance, scalability, security, portability, and other criteria for quality. the maintenance and operation is, yeah, you won't use a blockchain application, but is it what do you do in case if there's a bug? Who's gonna fix it, or who's gonna operate if you want to extend the blockchain with another function? And another requirement could be the cost. It's like how much does one transaction of block cost, or how much does it cost to run a blockchain? And the second, the next one would be the functional perspective. Is it easy to implement the blockchain in other solution, or is it extendable, or something like that? And there could be many different other requirements, like it's a meeting the government restriction, not meeting if there is a government restriction and you have to see if you could use it, like you have digital certification, but if the government does not accept it, so it does not make sense to use it. So we are more focusing on the quality perspective, as there are many requirements to choose which blockchain do you want to use, but to talk about all these requirements would take a day or even a week. So we are focusing more on the quality perspective in the security area. That's why I talk about the threads and the consensus mechanism and how they are connected to each other. So blockchain, I assume that everyone already heard of it. And so what is it exactly? So I have a good quote from an Andrea, and he said that the blockchain does one thing. It replaces third trust with mathematical proof that something has happened. So it's like you have Alice and Bob, and Alice wants to transfer money to Bob, and usually there is a bank that says, yes, Bob has the money and he can send it to Alice. So in this place, you replace the third party, so there is no bank. So you use the mathematical proof to add information to your blockchain. And everyone has a copy of this blockchain, and this blockchain says, yes, Bob has this money and he can send it to Alice. So here are the next one are some characteristics of blockchain. It's like a type of distributed ledger. There can be many other distributed ledger. Blockchain is one implementation of a distributed ledger. So there's another example is like IOTA. It doesn't use blockchain, what I've read. It's not like you have a chain of blocks. And as it is a distributed ledger, there is no central authority. And it's like an open book, and everyone has this open book. So you can keep track the provenance, so you can just go to the first page and say, who was the first one who owned this money? And then you could go to the last page and see like, okay, this person owns the money and he can spend it. And the second one is the transaction irrevocability. That means that if Alice, no, it was Bob, if Bob wants to spend money to Alice, and he said, no, I want my money back, I reverted just like the revert button. No, that's not possible anymore. It's once it is in a blockchain, it will stay there. And he can also not double spend it, like, I send it to Alice, and at the same time I send it to Johnson. And the third one is like it's encryption for security and privacy. So it's an open book. Everyone has a copy of this open book, but you can't read this book. It's like it's another language from another planet. So you have this book, you have all this information, but you can't read it because it's encrypted. So only the user who has this his key and his certificate to prove that to him belongs this money and he can spend it. So only the person can do this transaction. So it's an open book and nobody can read it. And again, I want to highlight there is no central authority. The distributor letter said itself there is no central authority. So without a central authority, you can save money like the transaction cost, or you can improve the performance. So the next one, I will show you an example with Bob and Alice. I think Bob and Alice is like a common use example for message sending from sender to receiver. And here you see an example how a transaction looked in the Bitcoin example, but because the implementation differs from other blockchain applications implementation. So this is just an example. Like Bob wants to send money to Alice because he wants to buy the house from Alice. This is something like not only cryptocurrencies but also smart contracts. So she just the use case, she deployed her code on the blockchain network and register her house in this smart contract, and raised like the condition, yeah, the house could cost like 100 Bitcoin and it belongs to her. If you want to buy it, send it her 100 Bitcoin. So Bob has this money and he could request the transaction and broadcast it to the P2P network, within a blockchain. And the miners, the one who did the work to validate and maintain the blockchain, first validate if the transaction is valid, and the user status, like he checked, does this house exist? Does this belong to Alice? And with Bob is, does he has the money and can he spend it? And if the validation is authorized, it will be combined with other transactions. So you can create a new block with not only the transaction of Bob and Alice, it has many other transactions. In the Bitcoin example, it's like every 10 minutes a block will create it. Other implementation can have different mechanisms. For this one, every 10 minutes a new block created with many transactions. And the miners, the one who will maintain and authorize the blockchain, in the case of Bitcoin, it solved a mathematical puzzle and added it to the blockchain in the end. If he solved the mathematical puzzle, he have this block, and he added to the blockchain and notify all these other nodes that that he found the solution for this block. So the other ones stop trying to find a solution for the new block and accept the block from the first one who solved the puzzle. So the next one is how a block inside a block could lose like. This is also a Bitcoin example. I use it because it's easier to understand. There are some other solutions, but it's more complicated. So you see one block. It consists of the block header and the hash of the previous block header. It could have some more information, and the macro root. And inside the macro root, there's like transaction of blocks. And it's like it's always reference to the previous hash of the block header, so it is connected like a chain together. Like you have a book. In one page, you have all these transactions. On the next page, you write a new page with all these transactions, so they are all connected to each other. So how does a block exactly look like? It's also a Bitcoin example from Melanie Swan, a good book I can also recommend. And here, how does it look like? I don't want to go into detail, but just to give you a feeling how it would look like. And the previous block header is a hash, and you have like the timestamp, the difficulty. It says how difficult it is to create a new block. And nonce means number used only once. So the miners who create the block and maintain the block, this is like a variable, and he can put some, he can select the money and try the number, and he tried to find to solve the puzzle. So that's why he will try it out and make different inputs to meet the requirements to create a new block. And the macro root would look like also like a hash, and it consists of all these transactions. So we have like these blocks that added to the blockchain, and we have some kind of mechanism and process behind that everyone agreed that how a block is added to the blockchain. But if in case there are two people who created a block at the same time, which one do you use? And how does it work? It's like two people, two miners at the same time created a block, and then it broadcast to the network and said, yes, I found a block, and this is why there have something to be a consensus. Here is an example, like I can also use a block, but I use the ledger like an open book, and the numbers state that it's like version 1, version 2, version 3, and version 4 that exists in the broadcast. There are even some nodes who have only the old blockchain version. So how do you know if which blockchain do you use on a network? And there can even be some fork blocks, like the broadcast network is very slow, and another miner has already created two blocks, that would be 2A and 3A. And other nodes get information about 2A, 3A, and the 4.1 and the 3B. So which one does he take? How do we know which one is the current blockchain? And yeah, in the Bitcoin example, it uses the latest blockchain, the largest blockchain, is the one who will take it. So it's the number 4. So these are the fake ones or the too slow ones. It's also called the ghost protocol, I think, that if a miner is too slow and another found already the block and spread it to the network. And the nodes have to know that this one is the right solution. So that why a consensus mechanism is needed, so everyone has the same state of this blockchain, of this book. On that version 1 and not version 2 is on only the current version, the 4th version, and not like 2B or 2A. So everyone has some kind of consensus which blockchain he has to use and how the mechanism is to add a block to the blockchain. Yeah, about the security threats. So I will introduce you to some security threats that exist in the blockchain network. So there are just some well-known attackers, threats that could exist in the blockchain network. It can be much more. This is like the common one I found in my research. And if you ignore the threat, it can lead you to the huge amount of loss of money. And first of all, I will go to the 51% attacks. It's very well known, and it occurs if the miners has like 55% of the hashing power, and that results that he can change the transaction and he can change the block. So he can double spend, like spending the money twice, even if it's not in your account anymore, and he can manipulate the blockchain if you have like 55% hashing power of the blockchain network. And the other one is the long range attack. It's the same as the it's the same as the 55% attack. It's only that that they change to manipulate the blockchain from the Genesis blockchain, also from the root blockchain. And yeah, and the next threat would be the distributed denial of service. It's like you keep attacking a node so it couldn't get the resource, like there's a new block added. So the nodes are getting not the up-to-date information if they get attacked. So the P epsilon attack, this is more like a bright mechanism. It's like if one attacker is willing to pay money to the nodes that they said, yeah, we accept this transaction, it's okay because you gave me money. And if he have enough money, he can also manipulate the blockchain to his will. And the balance attack is, let me check. It's like it's delaying the network communication between subgroups. So if there is one node, try to solve the puzzle and said, yes, I found it, I send it to all these, I give the information all to these others node in the blockchain network. But there is an attacker and said, no, I will slow your information down so it gets slow, and I will create a block before you and spread it and broadcast it to the network. So he gets the incentive. He gets the money for creating a new block because the other one was too slow. And the next one is the broader gateway protocol hijacking. It's like if a service provider makes false announcement over the routing system to divert traffic. For instance, let me think about it. He can obstruct, same example, one created a block, broadcast it to the network, and then it's get in another direction, so it can obstruct the current block and create an old one with the false transaction inside in it. And yeah, back to the 55% attack, we go deeper into this detail, because on the next slide I will explain you what could what 51% attack could reach. So here are like some kind of definition. It occurs when, like I said before, 55% of the hashing power exists, and the attack is starting. That attacker is secretly generating the blocks. And when he is the largest block, because in the Bitcoin rule is like the largest blocks win, they take always the largest block. And if there is like block 1, 2, 3, and the attacker starts with block 2 and has secretly created block 2 and 3, so everyone is gonna 3 and 4, and everyone is gonna use the fake one because they said it's the largest block rule, so we take this one. And so the isolated chain will then be distributed to the network and said, yes, this is the up-to-date blockchain. And yeah, as I said before, blockchain complies with the longest chain rule. And but to say cryptocurrency with 5 network hashing, like the Bitcoin, it's assumed to be more secure because there are more participants, and it's hard to get 55% of the hashing power. It's like you have to get an entire country power of that. And yeah, we will go to the next one, and what 55% attack can lead to. And here's some example of coins that has been affected from the 55% attack. And people say that no, this could never happen, that 55% attack in a blockchain network. Yes, it exists and it happened. And it's just one security threat. And I introduced you like 6 other, and it could be more. And this is like one security threat that could lead to a loss of $80 million. On the bottom you will see the reference of it. And yeah, and it's like Bitcoin Gold. It's like the extension of Bitcoin. And they were affected to the 55% attack and lost like $18 million. And that's pretty much. It's much more I would ever earn in 1 year. Yeah, and there are some small ones. And if you can see, threats don't have to be ignored. They can lead to a huge loss of money. So that is why it's really important to look, not just because it's blockchain, you just don't have to think about, yeah, it's blockchain, I use it, and it's okay. Where the implementation is also very important. There exists many different consensus mechanisms in the market, so you have to look, not only this is the name blockchain, you have to look how does he implement it, what kind of consensus mechanism is he using. And here I'm going to introduce you to the 3 classic ones: the proof of work, the proof of stake, and the delegated proof of stake. And there exists some more. Okay, it's just like 3 pages more. So here I give you an overview of the consensus mechanism. And you have like the proof of work, and it's the one that Bitcoin is using. It's like new transactions are authorized and recorded, proved by the miners. As I said before, they're like nodes providing their resources, and it's based on mathematical equation, and they select the longest branch. So, and the proof of work assume that it has more than the half of the nodes are the honest one. So it's really prone to the 25% attack if the hashing power is very low. And the proof of stake is like you authorize block based on the stakes. This means the more money you have, the more you have the power to create a new, to validate transaction and to create a new block to the blockchain. And this idea was because they want to keep the mining, the process and the mining power low. So it's not that expensive. And the delegated proof of stake is like the more money you have, the more you have the power to vote for delegates and witnesses. As before, for a different definition, for different words for that. So the delegates, they vote for delegates, and the delegates are responsible for validating transaction and maintaining the blockchain. And there's also the main idea to use the energy enhance speed transaction, because Bitcoin is very slow. It's like it needs a lot of energy, and it takes 10 minutes to add a new block, and they want to use it. These other two consensus mechanisms want to make it much faster and still safe. And there could exist many other consensus mechanisms. I read there is like a proof of learning mechanism which include machine learning, but I didn't read this too much into detail. So there are how the comparison between these three classic consensus mechanisms, and just give you an overview that the old one, the proof of work, which Bitcoin is using, does need much energy cost, and the processing speed is very low, like every 10 minutes, and the decentralization is very high. And the other one is really fast, but the third one is with the decentralization is very low, because the more money you have, the more power you have to vote for someone who can generate the block to the blockchain. And where you see the attacks I introduced you to before, and if they are vulnerable, if they are weak to the attack or not. And if you can see, it's like 90% of these attacks are possible with the classic blockchain. So you need the extension one, not the old one. You need some better consensus mechanism, not the classic one. The classic one are very vulnerable to the vulnerable to attacks. And yeah, we're coming to the end, to the conclusion. Yeah, there's some conclusion what I might want to say about my session. And blockchain is one implementation of distributed ledger. There could exist many others, like IOTA. Blockchain is one solution, but who knows if they can, if the future is like there are many distributed ledger that have its own advantages and disadvantages, or maybe distributed ledger is not the right solution for your use cases. You can also use a central ledger. So, for instance, if you have a TÜV certificate and TÜV is gonna manage this database, so you don't need a blockchain that everyone has a copy of it. And as I explained before, there exists many blockchain consensus mechanisms in the market, and each has its own advantage or disadvantage. So choose the right one that fit one in requirements, not the classic one, because you saw before it's very vulnerable to these attacks. So it's better to use the advanced one. So there are people who have further function or mechanism for these classic ones. And the security threats are not to be ignored in the blockchain network. As I show in the graphic before, it could lead to huge loss of amount of money. And especially the classic consensus are not the right one to choose. And yeah, what about the future of blockchain provider? Could be like that in the future there are only a few blockchain provider that established in the market. It's just like the email. When the internet was founded, you have your email address and there were so many email providers. But now I think the established one is like Google or Apple, and maybe it's happened to blockchain as well. So that there's only a few one that's going to use and all these others are obsolete. Or there could be that, that the blockchain provider or provider of the solution will continue to grow as there are more use cases. You can use the blockchain and it makes sense. Just like a shopping mall or just like a clothing store. You have the established one like H&M or Zalando, but you know there are some small store where you know, you just go in and see, there is like a jacket, it fit to you and you buy it from the small store. It's the same as the blockchain. You have your use cases and maybe some small use case blockchain provider or services fit to your criteria and your use cases. Yeah, and that's, we are in the end of the presentation. Sorry for extended. Any questions?
First of all, thank you. Thank you, Andrea. There is a question.
So now that you know how blockchain works, do you have any positions in any of digital coins? Or?
No.
No.
Yeah, now
Do you regret-
it's not a good
Do you
strategy to
regret
buy.
not having coins? Because again,
It depends, because it's not predictable if the coins is going to go high and low. It's like one day it's like 100% higher and the next day it's like gonna be very low. So that's why I didn't buy it yet. I should buy it like 3 years before. That would make sense, but now it's unpredictable.
First of all, thanks a lot for taking the time to explain the basic concept for people like me who have no idea whatsoever. And now I actually understand the previous presentation in depth.
Good.
So thank you for that. My question is kind of like the point of view from the dusty public sector in Germany, which is afraid of everything that's like of external, like cloud computing and anything like that. So my question is, do you happen to know if there's any kind of technical means to use this concept, like in a private environment, like in a private cloud? Can I build my own provider for the blockchain mechanism, or would that kind of tip the whole concept and wouldn't make any sense at all?
But there also exists private blockchain. It is like if you have if you just have a close number of participants who only who have all the same level and they can't decide which one is going to maintain the database. So you have all the same level and you want to create a private blockchain. That's also possible. And that would be safer because you only have like a selected participants, like the government and maybe 3 others, that will provide that the person belongs to this kind of digital resource. Yeah.
one last question, because lunch is already coming. Right? You might be able to smell it already. So quick question, quick answer.
Yeah, it's not especially a question. I just wanted to add that we already explained in our presentation that we use a private network, a private blockchain network. So only the purchaser and supplier which bought our product can distribute or can get the distributed data, and it's just a private session, so to say.
Okay. Thank you. Thanks for a hint, the notice. I think everybody's getting a little bit hungry. And because of the smell, probably, right? Because of the good smell that is coming out of the kitchen. Thank you, Andrea. Very interesting. Let's have a lunch break.